To give a basic introduction of the game that we have developed, this project involves creating a Simon Says game, Simon Says memory game using 4 push buttons. The user interacts with the game through those push buttons representing the 4 colors, red, blue, green, and yellow. Apart from all of this, we also have another reset button on the FPGA board, the V18 one, which is for resetting the game. The game begins with the system displaying a random color, and the player must replicate the sequence. So an example of this would be that the system has chosen the color red. So the player has to press the push button representing the color red. Then the system chooses the color red green. So the player has to choose the color red and green and so on and so forth, increasing the difficulty of the games as the levels increment. So with each correct input, the system adds a new color, increasing the difficulty. The score is displayed on the screen at the bottom. The score increments by 1 each time the player gets the color generated sequence right. And the display visually represents the sequence by illuminating the corresponding colors, whichever color the system chooses or the user chooses. The rest of the colors are a bit dull, and that particular color brightens up a little bit. So it dynamically updates the player's choosing. The system is designed to provide an engaging and challenging experience while promoting cognitive development and enhancing memory skills. The project also encapsulates the sophistication of digital logic principles deployed in the realization of an engaging and interactive gaming experience. So I will be explaining the flow diagram for the Simon Says game. So the game starts with the display screen of the starting screen of which says game begin. And if we press any of the 4 color buttons, the push buttons, the screen transitions to the game screen, which shows 4 blocks, each of different colors, red, blue, green, and yellow. And so the user then has to replicate the color sequence through those push buttons. He has to replicate whatever sequence that the system has generated. Now, there are 2 conditions over here. The diamond represents the condition. If the user matches the sequence correctly, like replicates the sequence correctly, then the score on the FPGA increments by 1, and the system then adds another color to the sequence. And there's this whole cycle, as you can see the arrow going back. So the whole process then repeats, and it keeps on repeating, and the system keeps on increasing the score and adding colors as long as the player replicates the sequence correctly. However, if the player does not replicate the sequence correctly, if the player, let's say, skips a color or presses the wrong color, then this indicates the player has lost the game, and the score then resets to 0, and the screen transitions from the game screen to the end screen, which is the game end screen. And after that, you have to press a reset button, which is on the FPGA, the V18 button, and this reset button transitions the game end screen to the game start screen, as you can see the arrow going.
Moving on to the implementation of the game, I'm going to show you how the game basically works. And firstly, when we start up the game, this is our begin screen, and pressing any of the buttons. So firstly, for the inputs, we have the buttons, the push buttons. Right now we were not able to actually implement the external push buttons into the game, but we have right now implemented these push buttons, the FPGA push buttons, and these correspond to the color that we have right here. So the left one is the blue one, the top one is the green one, the right one is the yellow, and the down one is the red one. And this on the 7 segments display basically shows our score, and this is our external speaker that we have used using the A14 pen. So starting off, we can press any of the buttons to transition from the game begin screen to the game running screen. So let's do that, and this shows us a color, a sequence basically that builds off one after another. Starting off, we have the yellow, which is of course the right button. So when we press that, it gives us a sound, and now we have to, the sequence builds up, and now we have to press the yellow and the yellow again, and it basically builds up the score as well. So now it goes yellow, yellow, green. So the right one, and the top one, and it basically builds off how many times you want. It's up to the memory of the player of how good he is. And let's say right now the score is 3, but let's say I get the sequence wrong, and it plays a sound and the game ended. That's the screen we're going to show. But let's say we want to reset the game, there's a button exactly to reset the game, which is the middle button of the FPGA, and we press that, the end, it will go back to the game begin start, and then we can just play the game again. The of course score increments back to 0, and the sequence again shows. So I got the sequence wrong first, but that's again the game screen, and we can go back to the game again. So now I'm just going to play the game and build up the sequence. That's as far as I could go.
While working on this project, one of the biggest struggle that we came across was implementing the push buttons into our code. We were not able to do that as of now, which is why we were using the FPGA buttons for playing our game, but we are still trying our best to implement these push buttons into our code. What our initial idea was that we are going to make use of these push buttons, and then we are going to use these handmade buttons in pushing this button so that we could trigger the response. But as for now, we were not able to do that. Our second initiative was to use the touch sensors if the push buttons don't work. Apart from this, struggling thing was finding the exact coordinates of each letter so that we could make the start and the end screen. We managed to pull it off.
This is the FSM state transition diagram for our game, and we only have 3 states, which is the game initiated state, game running state, and game over state. So from this diagram, we can conclude that our game follows the logic of a Mealy machine, which says that our output does depend on the current state and input. So we only have 2 outputs. One is the score on the FPGA, and the other is the colors displaying on the screen. The FPGA score only increments by 1 if the user presses the correct push buttons representing the correct color sequence, and the output on the display also displays when the user presses the respective color for that push button. So both the FPGA score and the display are dependent on the current state and input.